Hello, I'm Barbara Clendon. I work at Statistics New Zealand. It is a fun place to work, and one of the things that I do in my work here is do some time series analysis. At Statistics New Zealand, we're more concerned about explaining what's happening in a series rather than forecasting the next value in the series. So what I'm going to be sharing with you today is mostly about explaining what's happening in the time series rather than forecasting. I'm going to show you two series today and we'll have a chat about those. The first one is a retail trade clothing series. It's a quarterly series, which means that every quarter the amount of sales is measured from stores that sell clothing, soft goods, that kind of thing. So let's have a look at the series and see what it can tell us. So looking at the latest point in the series, which is for the June quarter 2005, there's a really high value here. It's 597 million. So we could compare it to the last point, which is a natural thing to do. And there is the last point, $519 million. So we could say, well, in the last quarter, there's been a 15% increase in clothing and soft goods retail. But that really would be a bit misleading because it's really not a 15% increase at all. The June quarter is always higher than the March quarter, as you can see in the series. June always higher than March. June always higher than March. Another thing that should have really struck you very early on when we're looking at this graph is that it is highly seasonal, which means that every year there's the same kind of seasonal pattern. There's December quarter, March quarter, June quarter, September quarter, and that pattern is shown all the way down the series. So what we really want to do is remove some of that seasonality from the series to see what it would look like without that seasonal pattern. So let's have a look at that. You may ask how we got that yellow line. That's a good question. We use a package called X12 ARIMA. It was developed in the US Bureau of the Census, and it is used in quite a few government agencies around the world to do some seasonal adjustment on series. It uses a system of moving averages, which is it can be quite complicated. There are different moving averages used for trend and for removing the seasonality, and it is an iterative process, which takes account of all sorts of other things as well. Now, in the Year 13 syllabus, you do some seasonal adjustment and calculation of trend. And this is very similar. What you do is just a simplified version of this complicated process. So it should be highly relevant. Okay, so here we are looking at the seasonally adjusted line. Now you can see that it's a lot smoother than the actual series, indicating that the seasonality has been accounted for. So now when we're looking at this latest value, the seasonally adjusted value is $584 million compared to the previous value, 567. You can see that accounting for the seasonality, there has been an increase of 3%. And that makes a lot more sense, so that people are not going to get worried or overly excited about things that are happening in the economy. They are getting a much truer picture of what is happening. So this yellow line, which shows the seasonally adjusted series, still goes up and down, has extra wiggles in it. And so you can see that some of the increase in this line is due to an increasing trend. So we can see clearly that the clothing and soft goods retailing is increasing. And some of the wiggles in this line are due to what we call irregular, things that just happen in each quarter, quite apparently randomly, although sometimes there's a good reason why something might be going down or up for a particular quarter. X12, the computer package I was telling you about, also calculates the trend. And this shows a picture of the trend line in here as well as the seasonally adjusted line. The trend line is actually a smoothed version of the seasonally adjusted line, so that is how that is obtained through the magic moving averages again. So you can see that for this point here, which is December 2004, the seasonally adjusted value for that is quite a lot lower than would be expected just looking at the trend. So then the economists can go away and sort out why that might be. But you can see we're fairly much just showing the trend, and there's not much irregular there. When I'm talking about all these things, like trend and seasonally adjusted series and irregular, it's a good idea if you can see the model that we use. The time series model that's used by X12 is a very simple model. It assumes that the actual series is a combination of the trend cycle, which is the long-term changes in the series, the seasonal component, which takes care of the things that happen each month or each quarter, and the irregular component, which is whatever else is left over. We abbreviate that in symbols, as one does in mathematics or statistics. So that is the actual series equals CSI. C is the symbol for trend cycle, S is the symbol for seasonal component, and I is the symbol for irregular. And in most of the economic time series that we use, a multiplicative model is appropriate, which means that the trend cycle, the seasonal component, and the irregular are multiplied together to make up the actual series. One really good thing about X12 is that no other structure is assumed in the series. There's no rule about how one value has to lead on to the next value and so on, as there would be in other kinds of modelling. Now, the seasonally adjusted series, which we've been looking at, that was the yellow line, is the original series, the actual series, without the seasonality. So here we show that, the actual series divided by the seasonal component, which leaves the trend and the irregular. And this is a chart which shows the components of that clothing series. So in the top section, we have the actual series, just as we had in the original graph. The seasonal component is shown here. Now, this is not the seasonally adjusted series, remember, because the seasonally adjusted series is the actual series without the seasonal component. So here is the seasonal component. You can see how regular it is, quarter to quarter, and that's just smashing. See, it's a lovely seasonal series. The next panel shows the trend. Now, this is the underlying movement in the series. You can see that mostly recently it's been increasing. There was a little flat bit here in 2003, and things were looking quite rocky as far as clothing sales went until the beginning of the year 2000, as it started to rise there. Now, this needle-looking thing at the bottom, on this chart it's called remainder, we choose to call it irregular, that shows the little oddities that happen in each quarter. This is showing that there is a March Easter. Usually Easter is in April, and so the seasonal component takes account of when Easter's in April. But when Easter's in March, it changes the sales pattern. Here you can see that March was unusually high and April was unusually low. What you hope to see in these irregulars is you hope to see no pattern. And here, mostly it's sort of up and then down. So mostly this is good, no seasonal pattern, no regular pattern in the irregulars. So we can say that this trend and the seasonal component here really isolate those components quite well. So we can use the seasonally adjusted and the trend lines to explain what's happening in the series. We'd use a seasonally adjusted value to compare this month's value, or this quarter's value, with the previous one. What we'd use the trend for is to compare over a long term, to see what the long-term movement is. The series I'd like to show you next is to do with building consents. Before you start to build a building, or a house, or anything, you have to have a building consent. And so the local authorities where you live get your application for a building consent, and then when the building consent's issued to you, they count that building consent and they count what it's for. The series that we're going to be looking at is the number of new dwelling consents issued. And this is quite an important economic indicator. The economists think that if there are a lot of building consents issued, that business is great, everybody's happy, they feel like building lovely new mansions 2 metres next to someone else's lovely new mansion. And so when there are a lot of new dwelling consents issued, the economy is looking good. When there aren't so many issued, the economy is looking a bit sadder. So let's have a look at that series. You can see that there are a lot of increasing and decreasing periods. There is some seasonality in this series, but it's not nearly as obvious as it was in the previous series. So the reason that I like to show you this series is that it's utterly different from the other one, and it points out some interesting things later in the series. Now, this is a seasonally adjusted series, and you can see that for this middle bit in the series, the seasonally adjusted series, and remember that's the actuals without the seasonal component, they're quite a lot smoother than the actual line. But when we get up here, this bit of the series, we see that the seasonally adjusted series is really not much smoother. Now that's an indication that the seasonal adjustment is not terribly good. The interesting thing about this series is that the process behind getting the data is the thing that's driving this series. In this very high October in 2002, there was an extraordinary number of consents issued for new dwellings. That was driven utterly by apartments. Somebody decided that, or a group of people had decided that in that month they were going to get building consent issued for 1,500 apartments in Auckland. So that was quite an unusual thing to happen, and it, of course, threw the seasonal adjustment program out. This next big peak is in June. Now, builders are very clever people. They knew that in July a lot of the building consent charges were going to be increasing. So they all decided they needed their building consents issued by June at the latest. So that meant that in June we had another very high value for that. This building consent series is also an indicator used by the Reserve Bank to set their interest rates. And so they tend to wait until the latest value of the series is released before they review their cash rates. So they're very interested in turning points in this series. How you choose or how you identify a turning point in this series is you use the trend. Now, if you look at the trend, you can see that it is going up and up and up and up even higher, and that is when the Reserve Bank kept on putting the interest rates up because they wanted to slow the economy. They thought that the economy was growing too fast and they wanted to slow it down. Then we had a decrease, and then we have a very strange thing happen. And what has happened in these last few months is that the legislation has changed. There are a whole lot of new rules about what you can and can't do with a building consent, and the number of building consents has dropped dramatically. Builders again knew, and developers knew, that the legislation was going to be changing in April, so again they made a real effort to get everything that they could done by March, hence this high peak in March. And then April, May, June, what happened was that the local authorities who were processing the consents weren't really geared up to do it in the new ways that they had to do it. And so to start with, they were just learning, so they were very slow, not very many consents were issued. And then they've gradually been getting through their backlog and getting better at it. And so you can see that the value comes up again. So when you're looking at a series to try and explain what's happened, it's really important to look at the real world effects. Because if you were just looking at the numbers here, you would think that the economy was taking a real dive, when in fact that's not the case. It's just the change in legislation that's made the difference. So apart from being really interesting to break time series up into its various components, it's actually really useful to be able to identify the seasonal component and remove it from a series, hence getting the seasonally adjusted series, so that you can compare 1 month with the next month, or actually 1 month with the previous month, so that you can see what's actually going on in a series. And the trend is particularly useful for picking up turning points, things when the economy is changing, things when social conditions are changing if you have a social time series. And I hope that maybe you'll be inspired to study statistics and find out these exciting things for yourselves.